Welcome to Module 1, Introduction to Graphing. In this module, we're going to talk about what is a linear equation, the rectangular coordinate system, and then we're going to graph some ordered pairs. Like all the modules, as you go through them, you'll see some icons in the upper left. This one means we'll talk about the process, some examples, practice for you, and then finally a self-quiz. Let's get started. So what is a linear equation? Well, let's look at the words linear equation. In the word linear, we have line. Yep, the graph of a linear equation is always going to be a line. And then, of course, we have the word equation. Now, there are some rules for a linear equation. First of all, when you graph it, it will always be a straight line. Degree of 1. Each term with a variable in a linear equation is of the first degree, which means that the exponent of each variable is 1. Let me show you some examples. X plus y equals 8. This is a linear equation. Why? Because x has the exponent of 1. Notice I don't have a 1 there. It's assumed. And y also has an exponent of 1. That creates a linear equation. Let's look at another one. Y equals 1/2 x plus 3. Once again, let's look at the exponents of our variable. We have a 1 and a 1. Cool. X equals -5y. Let's look at the exponents of our variable. They're both 1s. Cool. These are all considered linear equations. Variables. Each equation will have at least one variable. And in the ones we've looked at, we have an x and a y. But we could have something like y equals -4. We have at least one variable, and that's y. X equals 7. We have at least one variable, and that's x. Now notice these are both to the first power. So these are considered linear equations. Constant. Each equation may or may not have a constant. A constant is a linear equation. A constant in a linear equation is a value that doesn't change and isn't multiplied by a variable. I like to say it's not hooked to a variable. It's represented by a number that stands alone. Let's look at our equations here. 8 is considered the constant. Notice it doesn't have a variable hooked to it. 3 is considered a constant. It doesn't have a variable hooked to it. Now when I look at 1/2, that's not a constant because it's being multiplied by x or has a variable hooked to it. X equals -5y. There isn't a constant there. Y equals -4. -4 is the constant. X equals 7. 7 is the constant. Determine which equations are linear. Why or why not? Let's look at the first one. 2x minus 5y equals 1. What do you think? Is it linear or not linear? If you said yes, you are correct. And how do I know? The x is to a degree of 1 and the y is to a degree of 1. How about x squared plus y squared equals 8? What do you think? If you said no, you are correct because the exponent on x is 2 and the exponent on y is 2. No, this isn't a linear equation. Let's look at this one. Y equals 1/2 x plus 3. What do you think? Yeah, this is also a linear equation. How about y squared equals -4? Nope, this isn't a linear equation because we have y to the second power. How about y equals 12? What do you think? Yep, this is a linear equation. How about this one? X to the third equals -5y. Nope, this is not a linear equation. The reason is x is to the third power. We only need one exponent to be something other than 1. And that makes this not a linear equation. What about the last one? What do you think? If you said no, you're correct. We have x to the second power. That makes it not a linear equation. Even though y is to the first power and 3x is to the first power, We only need one exponent that's not a 1 to make it not a linear equation. Let's look at a real-world example. YouTube allows users to change the speed of a video playback with options like 0.25x, 0.5x, and so on. Each step up or down is a linear change in the input, the user selection, which directly affects the output, the speed of the video. If you look at a video, to see that, press this icon, and then this will come up, your playback speed. Here's how it might be represented in a linear relationship. If a user selects 0.5x, the video plays at half the normal speed. Selects 1x, plays the video at normal speed. Selects 2x, plays the video at double the normal speed. Now, what would that look like as a graph? Now, here's something new. For linear equations, x is considered the input and y is the output. So the input x is down here on the bottom. That's where you select the speed. This is the y value. We're going to talk about that in just a second. But this is the playback speed. So for instance, if I wanted to play half the speed, I would press 0.5. Notice that would be right here in my playback speed. So what happens? Well, it plays back at half the speed. If I select 3/4 speed, that's what I get. And 1, and so on. That makes a linear equation. Now this is a very basic linear equation, but it gives you an idea of what we're looking at. Now let's talk about this graph thing. The rectangular coordinate system. The graph is called the Cartesian plane, named after the mathematician René Descartes. It's also called the Cartesian coordinate system, the coordinate plane, rectangular coordinate system, which is what you usually see in a textbook. In this system, we have a dark vertical line. That's called the y-axis. The y-axis is the thick line that runs vertically on the graph. And then, of course, you can see we have this one, the x-axis. The x-axis is the thick line that runs horizontally on the graph. Now notice how they're labeled. The very center is 0. And as we go up, we go 1, 2, 3, we go in a positive direction. As we go down, we go in a negative direction. Now let's look at the x-axis. As we go to the right, we go in a positive direction. And as we go to the left, we go into a negative direction. The graph is divided into 4 quadrants. The quadrants are always labeled with Roman numerals and always counterclockwise. This is quadrant 1, 2, 3, and 4. We're not really going to get into that in this workshop, but when you get into trig or calculus, you will be talking about the different quadrants, so it's important to know. The words plotting and graphing mean the same thing. And how do we graph? Well, we have something called an ordered pair. Ordered means it's in order, and pair means we have 2. 2 numbers written in order to make a point on the graph. Yeah, an ordered pair. Those ordered pairs are always x, y. 1 point from each axis. Notice the x-axis and the y-axis. The points are listed in alphabetical order, separated by a comma. This is really important. Students always mess this up. Remember, alphabetical order, x, comma, y. And finally, always place a parentheses around the numbers. Please, please, please. If you just write like 5, 7, that's just 5, 7. But when you put a parentheses around it, it means an ordered pair. Don't put something other than a parentheses because in math that means something else. So the parentheses is really important. Let's graph one. Remember, we have x, y. That's for the x-axis and the y-axis. So let's graph the ordered pair 3, 5. 3 means I'm going to go to 3 on the x-axis. 5 means I'm going to go to 5 on the y-axis. Now notice I went to the x-axis and then the y-axis. The only place you put a dot is at 3, 5, is where you end up. Let's look at another one. -6, 2. First, we have -6 on the x. I didn't mention this, but we want to start from the center first. Now we're going to go to -6 on the x, and then 2 on the y, and we put a dot. That's -6, 2. You're going to notice that I'm labeling these. It's a good idea, especially when you first start out. What about -9, -7? No problem. -9 is our x. We start from the center, also called the origin, which I'll mention in a minute. And we go to -9. From there, we go to -7. And we put our dot. That order pair is -9, -7. Let's try one more. 8, -4. From the center, we go to 8 on the x and -4 on the y. And we put a dot. And then, of course, I labeled it 8, -4. Cool. And yeah, that's as hard as it gets when we're going to graph ordered pairs. Now, what I want you to do is pause the video, graph the ordered pairs, and then press play to check. Let's see how you did. The first order pair is 7, 3. I go to 7 on the x and 3 on the y. Cool. The next one is 2, -9. I go to 2 on the x and then -9 on the y. How about -5, -1? I go to -5 on the x and -1 on the y. And finally, -3, 8. Well, we're going to go to -3 on the x and then +8 on the y. Remember earlier I was talking about the center being called the origin? Well, we have some special ordered pairs, and that's what we're going to talk about next. The first one is the origin. That's always 0, 0. That's always the center of our graph. It doesn't matter what rectangular coordinate system you're working with, the center is always 0, 0. Then we have what's called the x-intercept. The x-intercept is on the x-axis. Whenever we have the x-intercept, the ordered pair will be a number on the x-axis and 0. Let me show you. 8, 0. That's this spot. Notice that it's on 8 on the x-axis, but it doesn't go up or down on the y-axis. It stays at 0. 8, 0. What about -6, 0? That's this one. It's -6 on the x-axis, but 0 on the y. It doesn't go anywhere. And yes, if we have an x-intercept, we have a y-intercept. The y-intercept is on the y-axis. The y-intercept is always 0 for x and then some number for y. Let me give you an example. 0, -4. We don't go anywhere on the x-axis, but we go down to -4 on the y. 0, -4. Let's look at another one. 0, 7. We don't go anywhere on the x-axis, that's why we have a 0, but we go up to 7 on the y-axis. The x-intercept and y-intercept are super important when you graph linear equations. And actually, when you graph any type of equation, they're going to be really important. All right, here's another self-quiz. Pause the video, graph the points, then press play to check. Let's see how you did. The first one is -2, -8. That means I go to -2 on the x and -8 on the y. The next one is 5, 0. That means we go to 5 on the x and 0 on the y. Number 3 is 7, -2. We go to 7 on the x and -2 on the y. 4 is 0, 0, the origin. That's the very center. And finally, -7, -9. We go to -7 on the x and -9 on the y. Great work! Okay, you're going to complete the rectangular coordinate system practice worksheet. Make sure to check your answers. Then when you're done, continue to graphing linear equations.